session, I'm going to discuss what is chemical formula, how to write chemical formula, what are the requirements of writing chemical formula, by using what method we can write a chemical compound formula. First of all, what is chemical formula? All these things we'll discuss. Chemical formula means what? Chemical formula is simply symbolic representation of composition of a compound. What is chemical formula? Symbolic representation of composition of a compound is chemical formula. You know, water is a chemical name. So, what is the formula, chemical formula of water? H2O. You know that. Carbon dioxide. CO2. Symbolic representation of composition means how many carbons are there, how many oxygens are there. That is nothing but composition. Composition of compound. Which compound? Carbon dioxide. If it is water, in water, hydrogen and oxygen. Two hydrogens and one oxygen is present. It is a symbolic representation. And two hydrogens and one oxygen means it is a composition. Symbolic representation of composition of a compound is nothing but chemical formula. And what is it gives what? Chemical formula gives exact number of atoms of same elements or different elements. Chemical formula gives exact number of atoms of same elements or different elements present in a chemical compound or chemical substance. Exact number, how many hydrogens are present, how many oxygens are present, or how many aluminum phosphate if you take, how many aluminums are present, how many phosphates are present, in phosphate how many phosphorus are present, how many oxygens are present. So it can give it can give the number of atoms of same elements or different elements present in a chemical substance. So what are the requirements to get a chemical formula? Chemical formula, to write chemical formula we need symbols of elements and their valencies, symbols of elements and their combining capacities. Symbols, you know, so in previous classes I given symbols of means different elements: hydrogen, helium, neon, argon, krypton, sodium, potassium. Like that up to 30 elements I given along with their masses and atomic numbers and their electron configuration also we have discussed. So combining capacity, valency, we have discussed in earlier sessions. In last sessions, we have discussed about combining capacities or valencies or variable valencies also we have discussed. So to write a chemical formula, the symbols of elements and their combining capacities, otherwise valencies are required. These are the requirements for writing formula. What are the requirements? Symbols of elements, then their combining capacity. Combining capacity is nothing but what? Here it is nothing but valency only. About this valency we have discussed in previous classes along with the variable valency. Okay, after writing this chemical compound, always if you see any compound, always positive part will be first and negative part comes next. So here, while writing chemical formula of a compound, positive part, otherwise metal, generally metals are electropositive, we have discussed it. Non-metals are electronegative. So here, while writing chemical formula of a compound, positive part, that is metal, comes first, then followed by negative part. Negative part is nothing but non-metal. You know, sodium chloride. Sodium chloride means what? NaCl. So in NaCl, sodium is electropositive, Cl is electronegative. Sodium is positive part, chlorine is the negative part. So always while pronouncing a chemical compound, first we have to pronounce the positive part, otherwise the cation, then next anion. Sodium chloride, it is so pronunciation it is good. But if you pronounce it as chloride and sodium, it is looks odd just like. So it is not correct to pronounce chloride and sodium. It is correct for this correct pronunciation is sodium chloride. So while writing chemical formula, always we have to write positive part metal first, then negative part non-metal next for any compound. If it has a positive and negative part, first you have to write positive part, then next negative part. Then how to write chemical formula after knowing, after fulfilling these requirements, symbols of elements, and combining capacities or their valencies. After knowing these, how to write chemical formula means we have to use crisscross method. We have to use crisscross. Valency of one element should be written as subscript of other element. Means a crisscross valency of one element is nothing but number of other particles, other compounds. While writing, if I explain how to write this crisscross method, you can get clarity how to write the crisscross method. And why we are using this crisscross method means actually to maintain electrical neutrality, to balance charges, because charged species are unstable. Any compound you can take, any species you can take, if they carries charge means it is very very unstable chemical species. If charge is, it may be positive charge, it may be negative charge. All charged species are unstable. So as to get neutral charge, they may accept electrons, negative charges, they may lose negative charges, or they may lose electrons, and gets neutrality. Here, as to get electrical neutrality, we have to use crisscross method. If you use crisscross method, then only we can get zero charge on that particular compound. So, if they maintain electrical neutrality, then only it is correct formula. If electrical neutrality is not maintained, after cancellation, if we get some positive charges, otherwise we get some negative charges, that formula is not correct formula. So these are the requirements. One more time reading. A chemical formula means a symbolic representation of composition of a compound, and chemical formula gives exact number of atoms of same element or different elements present in a chemical substance. Then to write chemical formula, the symbols of elements and their combining capacities means valencies are required. So while writing formula of a compound, positive part, that is metal, comes first, followed by negative part, that is non-metal. And crisscross method is used to write chemical formula, by which we get electrical neutrality for that particular compound. This information is required. Then how to write simple ions? I am giving here. After writing simple ions and their charges, their valencies, we can crisscross. So I'll give some examples for simple cations and simple anions. Simple cations are found by losing electrons. In previous class only we have discussed. Here I am giving examples for simple ions. Simple ions means only one atom is present in that particular ion, like chloride. So generally, negative ions will take ID ending. Okay, all positive ions otherwise cations end in IUM. End in IUM means, for example, sodium. Lastly, IUM, ammonium, IUM. So that all positive ions end in IUM, and all negative ions, all negative ions or anions end in ide or ate or ide or ane. All cations, otherwise positive ions, end in IUM, and all negative ions or anions end in ide, ate, or ide, or ane. Ide, it is simple ion. Ate or ite, these are compound ions. Means more than one atom is present in that particular ion. Otherwise, you can say polyatomic ions. Polyatomic ions. For cations, for polyatomic ions, or it is simple ion or individual ions also end in IUM. Here I will give some examples for cations. Here see Na sodium. Its number of electrons are 11. If we remove one electron, it will get stable electron configuration. So that its charge is +1. Here its name is sodium. Say IUM. Then K plus. It is potassium. Here then rubidium Rb plus. Rubidium. Then Ca plus 2, because the number of electrons in calcium are 20. If we remove 2 electrons, it will get 18 electron configuration, that is argon. So this is no calcium, IUM, aluminium, Al plus 3, aluminium plus 3 ion, because 13 number of electrons are present. After removal of 3 electrons, we will get stable electron configuration of neon. That many ions we can write. See, similarly, here N nitrogen anions are writing. Examples for anions. Nitrogen, atomic number 7. So as to get 10 electrons, it will require 3 more electrons. So that after adding 3 electrons, it will get -3 charge. So this is simple ion, no? Simple ions end in ide, nitride. Similarly, O, oxygen, its charge is -2. Why means its number of electrons here are 8. If I add 2 more electrons, it will get neon configuration, stable electron configuration. So at O -2, it is oxide, nitride ion, oxide ion. Then similarly, F minus, number of electrons in fluorine are 9. After adding one more electron, it will get -1 charge and attains stable electron configuration of neon. So this is fluoride. So for all these, we have IDE ending, simple ions. Similarly, Cl minus, it is chloride. 17 electrons are present in chlorine. After adding one electron, it will get -1 charge and gets NS2 Np6 configuration of argon. Similarly, sulfur, number of electrons in sulfur are 16. If I add 2 more electrons to this, it will get 18 electron configuration of argon. So -2. This is sulfide, IDE, sulfide. Similarly, here phosphorus I am taking. Number of electrons in phosphorus is 15 as per atomic number. So how many electrons it requires? 3 more electrons it requires. So that -3, 15 and 3, 18. So argon configuration. So this is the phosphide. And about 8 and 8, I'll discuss. In this session, we'll discuss about 8 and 8, how we can get those ions. 8 ions and 8 ions we'll discuss. 8, it is carbon, we can say carbon related. Ions are related to carbanes with negative charge. That is separately we'll discuss afterwards. 8 and 8, how we can get today itself we'll discuss after writing formulas with respect to these compounds. Some cations, simple cations are given here. Some simple anions are given here. So here I'm writing Na plus, then K plus, then Rb plus, these are cations, Ca plus 2, then Al plus 3, then magnesium plus 2. First group and second group cations and third group cations are written here. They are the cations. Anions N minus 3, then O minus 2, F minus 1, Cl minus 1, S minus 2, P minus 3. They are different anions. Some cations are given, some anions are given. By using these, how we can write their formulas will write. So here I written clear name also. N minus 3 nitride ion, O minus 2 oxide ion, F minus 1 fluoride ion. Simple ions, otherwise individual, separate one atom ions, not compound ions, or end in ide. And all cations, compound cations, otherwise normal simple cations also end in IUM. There is no difference here, but here there is a difference in pronunciation. So all these we have to remember. All these we have to remember. Now we'll discuss about how to write the formula by using crisscross method. Okay. See here, first water formula will write. You know, water is simple ion. Here OH minus ion is present. How we can get OH minus hydroxide ion in this session we'll discuss. But first simple compound water formula. How we can write formula of water. H2O you know, but how we got that? So here two ions are present. One is cation, other one is anion. Their valences you have tried. First you have tried. First symbols I am writing. Hydrogen is present. Then here OH group is present. So these are the symbols. And here I am writing valency. You know, hydrogen valency 1. OH also charge is nothing but here valency. Charge and valency difference is valency just number. Charge may be positive, charge may be negative. That charge is negative for anions, that charge is positive for cations. But while writing valency, just you have to write that number only. No need to write, no need to mention negative or positive. Then we have to crisscross this. So this valency you have to write below OH group. This valency we have to write below bottom side of hydrogen. Bottom side, whenever you write any number that we can consider as subscript. If you write top, that is superscript. Subscript and superscript. Here we have to write subscripts only. So here what is the formula now? H1 and OH1. Otherwise, two hydrogens are present. So we can write H2O, two hydrogens, one oxygen. Like this, we can write formula for which one? Water. And simple way is here already I written O minus 2. O minus 2. So symbol I am writing another way. Instead of taking OH group, here I am taking hydrogen and oxygen. The compound found by hydrogen and oxygen. Symbols I am writing here. What is the valency of hydrogen? Valency of hydrogen is 1. Because hydrogen atomic number is 1. If you add one electron, it will get the helium configuration. Otherwise, if you remove electron, also it can get stability. Empty configuration, empty shells also stable. Okay, let it be. Afterwards, we'll discuss about empty shells and how we'll get the charge. Here, 1 valency. For oxygen, already here, you know, minus 2 means here 2 I am writing. So, this value we have to write at the bottom side of oxygen. This valency crisscross. So, crisscross means this valency we are writing the bottom side of oxygen. This one valency of oxygen we are writing the bottom side of hydrogen. So, what formula we can get? H2 and O1. And while writing formula, we should take simplest ratio. We can take simplest ratio. That also we will discuss. See here, I am taking one more compound. That is, it is the formula of water I given. Then hydrogen sulfide. Hydrogen sulfide formula. What is the formula of hydrogen sulfide? So here one more I am writing H plus. Hydrogen is always carries plus 1 charge in cation, minus 1 charge in anion form. Whenever it combines with metals, it can take minus 1 charge. Whenever it combines with non-metals, it can take plus 1 charge. That also in further classes you can get clarity. Hydrogen and sulfide. From this we can write symbols. First we have to write symbol. hydrogen, then sulfur. Then below this I am writing valency. Combining capacity of hydrogen is 1. Combining capacity of sulfur, how much it is? Sulfur. Sulfide, IDE ending means it is simple ion. Sulfate is different. Sulfide is different. Okay. Sulfur, it is simple ion, no? Its valence is 2. Minus 2. But here writing 2 only. Valence is just number. So this we have tried here. And this one valency we have tried at the bottom side of sulfur. So by using this we can write the formula. Below hydrogen we have tried 2 valence here crisscross, here sulfur 1 H2S. Hydrogen sulfide formula is H2S. Similarly we can write different other formulas. See here I am taking aluminum chloride. Formula of aluminum chloride I am writing here. Aluminum IUM chloride IDE. Chloride means it is chlorine, simple ion. Aluminum, atomic number, symbols first, important symbols you have tried. Aluminum symbol Al, and its valency V. Otherwise the valency here 3. Why 3? Atomic number is 13. After removal of 3 electrons, it will get stability by attaining inert gas configuration of neon. So 3. Aluminum 3. And here chloride. Beside this I am writing chlorine. Chlorine valency, atomic number is 17. So as to get 18 electron configuration, it requires 1 electron. So minus 1 means here 1. 3 should be here, 1 should be here. So what is the formula by using these? Al1 Cl3. Al1 Cl3. Similarly, here I am writing one more. Sodium compound I am taking. Sodium phosphide will take. Sodium phosphide. Sodium phosphide. So what are the symbols? Symbol for sodium is Na. Phosphide means ID ending is there, so it is isolated atom. Here valency for sodium 1, for phosphorus 15 atomic number. So it requires 3 more electrons to get stability. So here I am writing 3. So this 3 should be taken as subscript for sodium. This one is taken as subscript for phosphorus. The lighting formula always you should write cation first. Anions follows cations. So here Na, how much? 3. Na3 and P. Sodium phosphide formula it is. Sodium phosphide. Similarly, here I am taking aluminum phosphide. Aluminum phosphide. Aluminum symbol already here written. Aluminum Al. Phosphide P. So what is the valency of aluminum? It is 3 plus 3, but valency is combining capacity, just number. Phosphorus 3 combining capacity minus 3. So here this value like this we have to crisscross. So what is the formula now? Al3 T3. But always we should consider simplest ratio. What is simplest ratio? Formula must be in simplest ratio. Always formula must be in simplest ratio. In simplest ratio, so this 3 and this 3 get cancelled. If you divide this formula with 3, so here 3 ones are, here also 3 ones are. So that final formula is ALP. Aluminum phosphide formula ALP. Aluminum phosphide. Like this we can write many formulas. Many formula we can write. Nitride also we can write. Phosphates also we can write. For example, if we take potassium nitride and calcium nitride, we'll write now. Potassium nitride, calcium nitride, potassium nitride. All these are simple things only, but for beginners, it is very important. Once you have, once you get grip on this, you can get some more things. For second year students, all they are simple things only. They may consider they are just silly explanations, but for beginners, it is very very important. If they know how to write formula, then only they can write reactions. Some compound react with some reagent and produces products. They give just sentences. In that sentence, what chemical compounds are given, that you have to write as reactants and products. Without knowing formula, it is not at all possible to write chemical reaction. So all these are basics, very very important for beginners. After knowing all these are silly things, but without knowing this, you can't go furtherly. So these are very important things you have to remember. Symbol for potassium, K, and nitrogen, nitrate, N. So valency, combining capacity, here 1 potassium, first group element, 1 19 atomic number. If we remove one electron, it will get 18 configuration. Nitrogen, atomic number 7. If it takes 3 electrons, then it will get neon configuration. Then this value, valency of nitrogen should be taken as subscript for potassium. Valency of potassium should be taken as subscript of nitrogen. So by crisscrossing, we can get K3N. This potassium nitride formula. Then rubidium oxide if you take. Here I am taking rubidium oxide. Symbol for rubidium Rb. It was first group element, and oxide means oxygen. So valency of these two, valency of rubidium is 1, valency of oxygen it is 2, because 8 atomic number, 8 electrons are present. If it accepts 2 electrons, it will get stable electron configuration. So it should be taken as subscript for rubidium, it should be taken as subscript for oxygen. Therefore, formula becomes now Rb2O. Like this, we can write many formulas. Many formulas. So, in next sessions, what we'll do is first we'll write compound ions, acidic radicals. In next class, not now. Today, I'll conclude here only. But in next class, what we'll discuss that I'm writing here, acid and acidic radicals. Acids and acidic radicals, that means anions. How we can write acids and acidic radicals. Generally, from acids, we may get some simple ions also and some compound ions. Compound ions also we can get, like sulfate ion. How we can write sulfate? How we can get phosphate or sulfide, phosphide? All these we'll discuss in next class. And similarly, bases, bases and basic radicals. Basic radicals means they are nothing but cations. So by the combination of basic radicals and acidic radicals, how we can write the formula? These are simple ions. Both simple ions are taken. But in next class is like how to write aluminum sulfate or calcium sulfate, calcium phosphate, sodium phosphate, then sodium sulfide. When you can write ite ending, when you can write ate ending. All these things in next sessions we'll discuss. Okay, thank you. Stay home, stay safe.